Next, another way to actually represent your distance, speed, velocity, and acceleration itself is actually by the use of graphs itself. So graph is actually a much clearer way to actually show you how your distance or your speed or your acceleration all change with respective to time. So you'll notice that most of the time that your axis, your horizontal axis will actually be time itself. All right. So if you notice in a distance time graph, your speed is your gradient, is your slope of the graph itself. Okay. So if you take a look at this over here, what does this graph mean? So which means basically you can just imagine at your distance is 0. Every 1, 2, 3, 4, 5, and so on and so forth, you'll notice that how come my object still remains at 0 distance? Basically, it is because my object is not moving. And because my object is not moving, your speed is also 0. So if you see horizontal line, your gradient must be 0. Okay, your gradient is 0. And because this is speed, okay, your gradient is your speed. It is 0 meters per second. Okay, so you can just say that my object is stationary, it is at rest. Okay, so let's take a look at the next page over here. So same thing, you can just imagine at the start, I am 6 meters away from my starting point. Okay, and after 10 seconds, my object is still 6 meters away from my starting point, which means yes. And if you notice, also a horizontal line, right? So if you take the gradient formula, which is take this guy minus this, right? So on top, what's your distance? So on top here is your change in distance. This one is the time taken. Okay, so for those who don't know what's the gradient formula itself, it is basically just your distance here minus distance here, divided by time here, divided by time here. So do take note. Okay, so 6 minus 6 is 0, 0 minus divided by anything, it will always be 0. So you can see over here, as long as you have a horizontal line itself, horizontal line just means gradient is 0. Okay. Now, on the other hand, if you notice, this is now a diagonal line upwards. Okay, now why do we talk about upwards and downwards itself? Just take note. All right. So diagonal line upwards, which means we have constant gradient. Okay. So how do we describe this movement itself? So you can see my number, I have a 0.6, right? So I'll just say I am moving with constant speed. So when you see constant gradient, constant speed, so just know that straight line, diagonal, is just constant speed. That's all. Okay, but if you know the number, you can say my object is moving with constant speed from 0 meters to 6 meters or something like that. Or you can just calculate it and you can say I move with constant speed of 0.6 meters per second. Now, these two are the rarer ones. Okay, they are a bit rare. So you can just imagine a bit special. Now, if you curve upwards, can you notice that your gradient at the start, you are flat, right now you're getting steeper, right? So your steeper gradient. So your steeper gradient itself, what does it mean? This means increasing gradient. So my gradient is getting larger and larger. That's why we cannot calculate, because every second your gradient is changing. Okay, because I'm increasing gradient, don't forget my gradient means increasing speed. Speed and gradient in a distance time graph is the same. So if you want to describe it, I will say my object is moving with increasing speed. Okay. So the reverse is true as well. What I mean by that is if at the start, okay, hang on. If at the start you are steep, but then you're getting gentler. So this is gentler gradient, right? So don't forget, if you up till now, if you forgot what is gradient, gradient is your slope. So you can see that your slope is getting softer and softer gentler and gentler, right? So which means you are having a decreasing gradient. And because I have a decreasing gradient, I will have a decreasing speed. So you can see over here, I would just say I'm moving with decreasing speed. So whenever you see a curve itself, right, your speed is either increasing or decreasing. You are speeding up or slowing down. That's all. But if you see a straight line just means constant something. So in this case, constant gradient, constant speed. Okay. So similarly, just now what we actually covered was a distance time graph. So basically, that distance time graph describes how, if I change as time increases, how would my distance change? How would my speed change? How does my object move? Okay, that's what he was describing. Now, in a speed time graph, similarly, is very, very similar. It's basically as time changes, how does my speed change? How do I accelerate? How do I decelerate? Am I moving faster? Am I moving at constant speed? And whatnot, all right? Now, this is an additional part. This is additional. So do take note. Okay, a bit special. It's just that now, other than just your gradient that you have earlier on, you also have what we call your area under the graph. So your distance is actually area under the graph. So if you see a rectangle shape, it's just rectangle formula. If you see a triangle shape, triangle formula. All right. So without further ado, let's go through. Now you can see over here, horizontal line. So ask yourself again, horizontal, what does it mean? Gradient is 0. Okay, and then ask yourself, what's your gradient? My acceleration is my gradient. It's 0 meters per second square, right? So if I have 0 acceleration, I mean I have either constant speed, but in this case, what's your speed? Your speed is 0. So my speed is 0, right? What does it mean? I am stationary. So in this case, how do you describe the object? The object is stationary. Because why? I have a horizontal gradient, which means gradient is 0. And what is gradient? Gradient is your acceleration. Acceleration is 0 meters per second square. So if you have 0 acceleration, what does it mean? I am not speeding up. I am not slowing down. So because of this, my speed is going to be 0. Because from the graph, you can see my speed 0, right? I will be stationary. So you can see actually the next point over here is actually very, very similar as well. Okay, so you can just hang on now. You can see that this is actually very similar. Just that in this case, my speed is not 0. My speed is now 6 meters per second. So what does it mean? I have constant speed. So how do I describe this graph? I will say I am moving with constant speed. And because, if you ask yourself, because I am moving with constant speed, that means I must move a certain distance, right? Every second, I will move 6 meters. So if you notice over here, the area under the graph, so under your orange color line, this is a rectangle. So what do? We'll take length times breadth. So your area of your triangle, rectangle is 6 times 10, right? So you can see that the distance traveled by my object is actually 60 meters. So in your 10 seconds itself, you traveled 60 meters. Okay, so acceleration is also 0. Why? Because it's a horizontal line. Horizontal line gradient is 0. So how do we say it? We will move at constant speed of 6 meters per second. Okay. Now, this part. So you can see over here, now you have a diagonal line, right? Diagonal. What does it mean? Diagonal means constant gradient. And because I have constant gradient, what does it mean? I have constant acceleration. So if I have constant acceleration itself, what does it mean? I am actually speed up. Okay, so you can see over here, you actually don't need to talk about the speed up part. You can just say, oh, I am moving with constant acceleration. And like the same as just now for your distance time graph, if I move at constant acceleration, you can say, oh, from time 0 to time 10 seconds, my object is moving constant acceleration from 0 meters per second to 6 meters per second. Basically, you can see that you are speeding up from rest. So from 0, you get faster and faster, faster and faster. And at 10 seconds, you reach 6 meters per second. All right, now this is the weird part. So if you notice area under my green color line, under my graph, right, you notice that this is a triangle. So you're gonna take length times half, length times breadth times height. Okay? Half length times height. Okay, so you can see over here, I'm moving with uniform acceleration. If you know the value, or you can say this part. So instead of saying speeding up, I can just say the word accelerating. And you want to say accelerate uniformly or constantly. Okay, uniformly. So you can see the distance itself is just half times 10 times 6. You actually move 30. So whenever you have a graph, we do not use distance equals to speed. We do not use speed equals distance over time. We do not. Okay, do not. Why? Because this formula assumes average speed. But the thing is, my speed is not the same. Okay, this one assumes must be constant speed. Because you can see my speed is actually changing. So because my speed is changing, I cannot use this formula. I must use the area under the ground. So we don't always use that one. I would say try not to use it at all, as much as you can, unless the question is just a speed distance time graph, a very, very simple distance speed calculations. Like there's no graph, it's just calculations, then yes, you can use that one. But otherwise, I would suggest that you actually try to draw a speed time graph or a distance time graph to make it easier for yourself to see. Okay, now if you notice down here, this is the part where being upwards or downwards come into play. Okay, now if you have upwards, what does it mean? This gradient is positive. On the other hand, if you have a negative, if you have a downwards, I just spoiled the answer, right? This is going to be a negative gradient. So you're going to have a negative gradient itself. So what does this mean? You can see that your speed is actually decreasing when time moves from 0 to 10 seconds. My speed is actually decreasing from 6 all the way to 0, right? So you are slowing down. So because I'm slowing down, I actually decelerate. So how do I? My object is moving with uniform deceleration. So I'm slowing down itself. So you can see, instead of saying slowing down, you can also say decelerate uniformly. Also can. Okay, so you can see the distance that you have, the area under the graph is still the same. It's still a triangle shape. So because it's a triangle shape itself, we will just use half times base times height. Okay, so because of this, this is how you draw your speed time graph accordingly. So, confusing, right? So why do we need to learn all of this speed time graph, distance time graph itself? Because the question will come up something like this, okay? It'll give you like a combination of a few. So what you're actually supposed to do is ask yourself, I'm going to cut this up. Okay, I'm going to split this into your 4 parts. So this question is actually very nice. They actually split it for you already. So you can see over here, you have P, Q, R, S. So now you just need to describe the motion of the car throughout the entire journey. So what you want to do is for each of the parts. So ask yourself, P, you can read what it is, right? Your Q, your R, your S. You can see actually they all are individual parts by themselves. So what we mean by this is from time equals to 0 to time equals to 2 seconds. What happens? Same thing, first thing you want to ask yourself is this. What graph am I talking about? So you have a speed time graph, right? So next, you want to remind yourself, what exactly is my gradient? My gradient will be speed over time. So change in speed over change in time. So this is actually your acceleration. So then what is your area under graph? Okay, because this is a speed time graph, we will have distance. All right, so first things first, let's discuss. So you see a horizontal line here, right? Horizontal. So what does that mean? Gradient is 0. So because gradient is 0, how do we describe? So you can just say the object, okay, the car, right, is moving with, because you have 0 gradient, I have 0 acceleration. So I will say 0 acceleration, and thus, actually you don't need the 0 acceleration, you can just say you are moving with constant speed of how much? 7 meters per second. Because you can see over here, this is actually 7 meters per second. So you can see in the first 2 seconds, I only move with 7 meters per second every second. So I don't actually move faster, I don't speed up, I don't slow down. So same thing, you just want to continue from there. So from 2 seconds to 4 seconds, what did the car do? The car is moving with, and because you can see, we started from 7, and you can see that we actually slow down, right? So what you can say is that the car is moving with uniform deceleration because I'm slowing down, and because it's a straight diagonal line downwards, it's a uniform deceleration from 7 meters per second to how much? 3 meters per second. So you can see over here, if you dot the line, this is 3 meters. So from 7 to 3, you can see we slowed down. All right. And as much as you can, if you have the space, try to separate them so that it's easier for the teacher to see. So same thing you just want to do for each and every step itself. So from 4 seconds to your 6 seconds. The car is moving with. So in this case, you can see it's a horizontal line again, right? So we are moving at constant speed of 3 meters per second. Same thing, last but not least, you have 6 to 8 seconds, right? The car is now, because if you notice the speed of the car is actually from 3 to 8, right? So you actually say uniform acceleration because I'm speeding up from 3 meters per second to 8 meters per second. So you can see over here, you have a diagonal line, then you have, sorry, horizontal then diagonal, right? So same thing, and with this, this one is up, this one is down, this one is up. So this is positive, this is negative. So you can see the answer. It is basically, we always say the object is moving with something. Okay, so in this case, you can see that on top here, this is actually 0 acceleration. Same thing for this. This is also 0 acceleration. Okay, so we always make sure to use our gradient to describe it. But for those cases where your gradient is 0, you want to be a little bit more specific and you want to describe whether it's constant speed, is it stationary, how exactly is it moving itself. So you can just picture the car, okay, it's moving at 7 meters per second. Maybe you want to slow down because it reaches a school zone and they drive a bit slower. And then once you leave the school zone, you can speed up faster, something like that. Okay. The next part, you want to determine your deceleration of the car. So the deceleration of the car itself is this blue color part that we have, this part. So first thing first is you need to remember deceleration has no formula. So what we want to do is we just use the standard acceleration formula and ask ourselves, we are moving from 7 to 3. So we are take 3 minus 7. And what's the time taken? Time taken is from 2 to 4, right? So you take 4 minus 2. Do you understand? Because we are just going to use this part of the graph. So you just need to ask yourself at this point and at this point, what happened over here? So what you should end up with is, you should end up with negative 2.0 meters per second. Don't forget, this is not your answer. You need to explain. Deceleration is negative 8. Therefore, I have a positive 2.0 meters per second square deceleration. Okay. Next part, read the question carefully. When the car is accelerating, what is the distance traveled? So they're asking you, what is this distance? They're asking you. So area under graph, you can see this part is actually a trapezium, but if you haven't learned the trapezium formula, what we can do is chop it up. So you can see this is actually a triangle and a rectangle, right? So all you need to do is write this first. Always important. Distance equals area under speed time graph. If you don't write this, you might lose marks. So please be important. Do take note. Okay? Now, I'm just putting the brackets to show you that there's actually two parts. There's a rectangle, and there's a triangle. So rectangle itself, 6 to 8, this is 2. And what's the height? Height is 3, right? Then for your triangle, it is half times base. Base is also 2. And what's your height? Your height is 1, 2, 3, 4, 5. You notice the units is 8 minus 3, so it's 5. So all you need to do now is press your calculator. You should end up with 11 meters itself. Okay, so that's double check. 6 plus 5. Yes, 11 meters. So this is your distance traveled when you accelerate for this period of time. Okay,